Welcome to another interesting question based on vectors. We are going to apply the concepts learned about dot and cross product to find the shortest distance from a point to the line. Very important question from test point of view. In case you want to learn from me, you can always send an email on the address given. Let us keep learning and enjoying the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss how do we find the shortest distance from a point. It is an extremely important topic on vectors. In case you want to learn from me, you can always send an email on the address given. The question here has been taken from previous test paper. I am going to suggest strategies to solve such questions in given situations. So as you can see the title, it says shortest distance using two methods. So that gives you an idea. We are going to discuss it at length. It is advisable for students to watch the video till the end. The question here is, find the shortest distance from point P minus 2, 11, 5 to the line with vector equation R 0, 2, minus 3 plus S minus 1, 2, 5, where S belongs to real numbers. We are given a point and a line. The vector equation of line is given to you. You need to find the shortest distance from the point to the line. You can always pause the video, answer the question. Now here are suggestions to attempt this problem. So let's see, how does this figure look like? So we have a line here, let's say, right? And that is R equals to 0, 2, minus 3. It really means that we have a point here. Let's call this point as Q. And coordinates of these points are 0, 2, minus 3. The position vector is given to us. 0, 2, minus 3 is the position vector, and the coordinate points of Q are 0, 2, minus 3. Then let's look into the direction. The direction here is minus 1, 2, 5. So along the line, if you go along this line, then somewhere, giving different values to S, you could have more points, and different values of S will give you different points on the line. So that is how the vector equation of the line works. Now let's look into the point P, and let's say the point P is somewhere there, whose coordinates are minus 2, 11, 5. When we want to find the shortest distance, the idea is that we need to drop a perpendicular from P to the line. And this perpendicular is the shortest distance, right? Let's call this point as N, where the foot of the perpendicular from P can be drawn. So, as you can see here, we can also, this is called foot of the perpendicular. From point P, right? At any external point for that matter. Many times the question is to find the coordinate points of the foot of the perpendicular, correct? So now you know, if you can find N, you can find P to N, distance between 2 points, right? Not difficult at all. So that means Pn could be equal to, we can use the formula, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So that becomes the distance from P to N and also the shortest distance. Now, how do we find point N? Point N could be some value of s, right? So we can say point n is basically equal to 0 to minus 3. And for some value of s, let's say t, right? So that gives you the coordinate point. So let me write down like this. Point n could be, let's add the coordinate points, 0 to minus 3 with some value of t, right? In the direction of minus 1 to 5, correct? So basically, I could write this point as 0 minus t. So we could write this as minus t. 2 plus 2t. Let me write 2 plus 2t. And minus 3, 5t, right? So let us say for some value t, the point n is right there so that Pn is perpendicular. So we now know n. So that gives you an idea. How do we find the shortest distance? Now the idea is that the dot product from P to n with the direction vector, let's call this as m, should be equal to 0, where we know that m is basically equal to minus 1 to 5. Is that clear to you? So using dot product, we can actually find the shortest distance. You get the idea. So that is method 1. Method 2 is using the cross product. The cross product says that let's join the point P to Q. So if you join P to Q, Q is another point. We are looking for Q. We are looking for Pn, which is like cos theta. Do you see that? Opposite side, sin theta, right? So we could use a cross product, right? Because we want the length Pn, which is sin theta, right? Sin theta is the cross product, right? And since the length has to be positive, we could write this as what? Well, clearly, we could write this as PQ cross with the gradient m, right? Magnitude of this, we're only interested in magnitude, not the cross product, but we know this is along that direction, correct? Divided by the magnitude of the gradient m. So that will also give you the distance from P to n. Does it make sense? And that is method 2. So I hope the procedure is absolutely clear, right? Let's see, how do we find the solution for this particular problem? A general solution, I hope, is absolutely clear. But the example always helps, right? So let's begin, and now we'll see how do we use dot product. So for dot product, we said we have to find what is P to Q, right? So for T, let's say point coordinate Q, we want to find n, right? So let's again sketch the diagram. It always helps. So what are we doing now? We basically have a point P. We have a point Q here, N and P. We are interested in finding P to N, right? N being on the line itself. So now, from here, let N be a coordinate point, which could be written as 0 to minus 3. We could write like this also, plus T times minus 1 to 5. Now, P to N will be what? P to N, P is minus 2, 11, 5, correct? So we have to use that here, right? So you could write this as, minus T, 2 plus 2T, and minus 3 plus 5T. Now, P to N will be, let's say, P n minus T you could write, or you can write P minus N, right? So P to N is N minus T. So we could write this as, let's say, minus T plus 2, then 2 plus 2t minus 11 minus 3 plus 5t minus 5. Is it okay? Which could be written as, let's rearrange. We write 2 minus t. Combine these numbers. We have minus 9 plus 2t. And we have minus 8 plus 5t. That is Pn. Now we know that Pn dot of m should be equal to 0, right? So that really means two minus t minus 9 plus 2t minus 8 plus 5t dot minus 1 to 5 equals to 0. Perfect. So let's find this out. So minus 2 minus t times minus 1 gives you, let me write a different ink. That gives you minus 2 plus t, right? Plus 2 times this gives us minus 18. So let me make this minus 18 plus 40. And that gives me minus 40 plus 25t equals to 0. So let's combine these terms. So we, as far as t is concerned, we have 25t plus 4, which is 29, plus 1, 30t, minus 2 and 18 is 20, and 40 is 60. So that gives us the value of t, right? So t equals to 2. Since we know that t is 2, we can now find what P2n is, substituting the value 2 in Pn, right? So now we know the vector Pn should be what? Substituting 2, we get 2 minus 2 minus 9 plus 4 and minus 8. 2 times 5 is 10 plus 10. That gives you 0, and that is minus 5, and this is 2, right? Minus and is 2, right? So the magnitude Pn is the shortest distance, right? So which is equal to square root of 0 square plus 5 square plus 2 square. That gives you 25 plus 4, 29, right? So square root of 29. Is that clear to you? So that becomes one of the methods of finding the shortest distance. And remember, here we also found the foot of the perpendicular from P. Perfect. So Pn is also helping us to find the foot of the perpendicular. We found the coordinate points n also, right? So this gives you foot of the perpendicular. That could be part of one of your questions at times. I hope this is absolutely clear. Correct? So I hope this is absolutely clear. Let's move on and see how do we use the second method, which is using the cross product to find the shortest distance. So let's again sketch the situation. We're given a line, and on this line we have a point. We're calling this point as a Q, and an external point which should be joined. We're looking for the shortest distance, correct? And this point P is given to us. Point P is minus 2, 11, 5, and point Q is 0, 2, minus 3. So we're looking for P to N, and clearly we can use the cross product, right? So we are saying the shortest distance is cross product of PQ with M over M. We are only looking for the magnitudes of each. since we are interested in distance, and distance is a positive quantity. Is that clear to you? So that gives you P to Q is minus 2, 0, right? 0 minus 2. So let's write it like this. So we are looking for PQ, which is minus 2 minus 0, 11 minus 2, and okay. So when I say P to Q, let me write Q first. Okay, so right, that is better. So we write 0 minus of this, that is plus 2, 2 minus 11, and minus 3 minus 5. Right, that is PQ. And we'll do this cross product with M, which is minus 125. Is that okay? So let's do the cross product first. So let's do what is PQ cross M. So I use the matrix method. That's simpler. So we use IJK, right, unit vectors, and the M is minus 125, PQ is 2, and 2 minus this is minus 9, and minus 8, correct? So that could be written as equal to I, 2 times minus 8 is minus 16, minus 9 times 45, right, plus 45, minus J, which gives minus 1 times minus 8 is plus 8, minus 4, minus 10. And the K component is minus 1 times minus 9, which is 9 minus 4. So, which is, we have 45 minus 16, which is 29I. And here we have minus and minus becomes plus 2, and this is 5, correct? So that is PQ cross M, correct? So now that is PQ cross M. That gives us one value. Let's find the magnitude of PQ cross M. So magnitude will be square root of 29 square plus 2 square plus 5 square, correct? And that is 29 square plus 2 square plus 5 square, and that gives you 870 square root. And let's also find the magnitude M. So magnitude M is square root of 1 square plus 2 square plus 5 square, correct? Which is 25 plus 4, 29, and 130. Right. So we have this cross product magnitudes, right? Now we can find the distance. As we said, distance is the cross product of PQ with M, magnitude, divided by the magnitude of M. And we found that PQ cross M is 870 square root, and this is square root of 30. So let's divide this. So we get square root of 0, 0 cancel. 3 goes 2 times and 9. Do you see that? So we get square root 29 as the shortest distance. So we can say that the shortest distance is square root 29. So both the methods gave us the same answer. You see that? But with that, the concepts of vectors, I hope, must have been absolutely clear. How are dot products and cross products related? How can we use them in many different situations? And that gives you a visual look of using or applying the concepts learned about dot product and cross product. In case you like this video, you may put some likes. Feel free to write down your comments, and in case you want to learn from me from the basic concepts and master the topic on vectors, You can always write to me on the given address. Most of my students get more than 90% marks. That should help, right? So, thanks and all the best. See you in the next video. Thank you.